All right, Honors Chemistry, this is your answers video for days 1 and 2, assigned on Monday and then on Tuesday for the period 3 class. So I'm just going to go ahead and work some of the problems, not all of them. Again, your examples watch the video, which is now up. I took down the PowerPoint as of Tuesday evening, and now the video is up. So go ahead and watch that. You'll see complete explanations as to how to do all these, but I'll go ahead and do some of them with you here. And now, one note about doing problems, you shouldn't just be copying. Try to do the problem on your own. And if you can't do it, then watch the video, but don't necessarily, especially if it's a long problem, as we'll get into some of those later in the course, don't just watch the entire answer. Watch just enough of it to where you kind of get an idea how to get started, and then try to do it on your own. And if you get stuck again, then watch the video again. Only watch it as much as you need to. The goal is really to be able to do the problem on your own without the video and do it correctly. And my real benchmark for when you can do a problem is if you can do it 3 days later without any notes or without any help, then you really understand how to do that problem. So that's one way to tell, to really judge yourself and kind of assess yourself as to whether you really know how to do a problem. All right, let's go ahead and get started with these. So we're going to do a fraction addition. The subtraction is done exactly the same way. So we're going to take this number and bring it over here. And the other one, the other direction, crossing arrows. 4 times 2 is 8. 4 times 5 is 20. You're going to add 5 times 3 is 15. And 5 times 4 again is 20. So you have a common denominator. Okay, so now you add the top. 8 plus 15 is 22. And the denominator you leave alone. I didn't ask you to do this, but if you want to change it to a mixed fraction, it's 22 divided by 20. Top number divided by the bottom. So let's do that. The 20 goes into 22 one time. That's 20. You're going to subtract that. You're going to get 2. And you're done with the problem. So the answer would be 1 and 2 over 20. But of course, you should always reduce a fraction. So 2 over 20 becomes 1 over 10. So it would be 1 and 1/10 if you wanted to express that as a mixed fraction right there. Okay? I'm good with this right here, though, just to let you know. Okay, you can do this one the same way. All right, multiplication. It's straight across top and straight across bottom. Do any cancellations you can. We can cancel the 2 and the 4. Again, you can only cancel across a multiplication sign, not a plus sign, not a division sign, not a subtraction sign. So 2 goes into 2 here one time. 2 goes into 4 2 times. Nothing else will cancel, so 1 times 3 is 3, and 5 times 2 is 10, and that's the answer to that. All right, again, always pause and try the problem before you watch the answer. I'll do the first 2 here, okay? So 2/7 divided by 4/5, so that's 2/7, and then you flip the bottom and multiply, times 5 over 4. And you have a 2 and a 4 that can cancel, so 2 goes into 2 one time, 2 goes into 4 2 times. So it's 1 times 5 is 5, and 7 times 2 is 14. If you do your canceling completely before you multiply, you'll never have to reduce your final answer. Okay, for this one, we're going to make a fraction out of 6, so we're going to call it 6 over 1 over 3 over 4. Now we have a problem just like this one, so we're going to flip the bottom and multiply. So that's going to be 6 over 1 times 4 over 3. Okay, 3 goes into 3 once, it goes into 6 twice. So 2 times 4 is 8, and 1 times 1 is 1. So 8 over 1 simply equals 8. All right. Okay, now number 4, really, really important to me that you set these up properly And it's not the answer, it's the setup that I want to see you do properly. Okay, so how many inches in 5.2 feet? You have to have a relationship between those two called a conversion factor. There's 12 inches for every 1 foot. So we can write that as two ratios. It's just simply one of this one over this one, and then this one over this one. So that's all you have to remember. It's 12 inches for every 1 foot, or there's 1 foot for every 12 inches. So those are both true statements, but only one of them is going to be helpful in this problem. So the way I like to set these up, I didn't exactly show it this way in the video, is we start off, first of all, what's the question asking for? You always want to ask yourself in any science question or any kind of question, what are we trying to find? What are you trying to get to? What you're trying to get to is inches. So what you do is that's going to be at the end of your equation, right? The answer to any equation is over on the right-hand side at the end of the equation. So I'm going to go ahead and write inches here. And just to underline, that's where you would put your final number answer with an equal sign, okay? Just like that. Now what do we start with? We start with 5.2 feet. So what you start with goes way over on the left. And I would usually, especially when we get into chemistry and you may have 3 or 4 conversions in a single problem, is leave a lot of space in the middle. So I'm going to come over here and write 5.2 feet. Okay, and then what I'm going to do is, you don't have to do this, but I usually like to do it. It kind of makes it like a worksheet. I've got to fill in something that's going to get rid of feet and make inches appear in my final answer, because that's what I want. So I have 2 possible choices there. They're both true statements, but which one are you going to want to put into this box so that feet cancels out and inches appears on the top? Well, the answer is the first one. Because if we put that here, 12 inches over 1 foot, remember that this is in the numerator, even though you don't see a top and bottom. I could write it over 1, in other words. So feet on the top cancels with feet on the bottom. And I call this the last man standing. The last man standing is inches, so that's going to be the unit in your final answer right there. So once you have the problem set up, now you can do the math. 5.2 times 12, you multiply everything on top and you divide everything on the bottom. So 5.2 times 12 divided by 1 divided by 1. Well, of course, that's just 5.2 times 12 in this case, but those aren't always ones on the bottom. So if I do that, I get 62.4, and that's the answer. Okay, how many inches in 4.1 yards? Okay, again, we're looking for inches, so way over here I'm going to write it here, because we're going to need some space for this problem. I think this will be enough room. I'm hoping I don't run out of space here. Okay, and we're going to start with 4.1 yards. Okay, now you might know how many inches there are in a yard, but I want you to pretend like you don't. Alright, so what we're going to do is we're going to need to convert from inches to feet, or excuse me, from yards to feet, and then from feet to inches. So we have 2 conversion factors over here, you'll notice. So that's going to leave me with a whole lot of ratios. So I'm going to start writing them. The first one is the same one as up here, but I'll write it out again. Okay, so there's 12 inches for every 1 foot, or there's 1 foot for every 12 inches. Then we have a second one right here that relates feet to yards, because we have to get from inches to yards. So we're going to say there's 3 feet. So I'm assuming in doing these first couple problems you understand inches, feet, and yards. Okay, so we actually have 4 conversion factors right here. 1, 2, 3, 4. Okay, that's a lot. Alright, then they're all true statements. There's 12 inches for every 1 foot. There's 1 foot for every 12 inches. There's 3 feet for every 1 yard. There's 1 yard for every 3 feet. Those are all true statements. But we're going to need 2 conversions, so I'm going to draw 2 of my boxes here. And they're both going to be ratio. Okay, so how do we fill in? Which of these do we put in here? Well, we see that we have inches in our final answer. That means inches is going to have to be on the top right here. Okay, so there's only one of these four that has inches on the top, and it's this one right here. So I'm going to write 12 inches for every 1 foot right there. Now, we start off with yards, but yards is not in our final answer, so we know that has to cancel out. So we need a yards that's on the bottom. We need a yards down here so it'll cancel with this yards up here. Those two will cancel, one on the top, one on the bottom. So we look over here for one that has yards on the bottom, and there's only one that does. It's this one right here, 3 feet for every 1 yard. So we put that here. Okay. So now if we cancel, we should end up with inches at the end. We want to. So yards on the top cancels with yards on the bottom. And look here, it's not just a coincidence, but it worked out. That feet on the top, because we don't have feet in our final answer, so we don't want it. We want it to cancel. But feet on the top canceled with feet on the bottom, so feet is gone. And the last man standing is inches, and that goes right there. So now that you have your units lined up, only now do you go and do the math. So it's 4.1 times 3 times 12 divided by 1 divided by 1. And so when we go ahead and write that, we get 147.6 inches. Okay? All right, let's look at number C. Now, I didn't leave any space for you to do this, so you can do this on the back of the sheet, or if you're doing it on lined paper, it doesn't matter. I don't even need to leave all these spaces. And lined paper is perfectly acceptable. Most students do it that way, but you're welcome to print this out. But if you do print this out, there's not enough space, so do it on the back. So this is the one that I'm going to leave for you to do. It's exactly like the one above in the sense it's two conversions. And so you start off, what do you start off with? What do you start off with? Sorry, what do you start off with is that. What do you want to end up with? Again, for the third time, it's inches. It doesn't always have to be inches. It just happens that that's working out here. And so I want you to do this one, okay? So that's one I'm going to leave alone, and you can do that one, all right? I'll go ahead and do D down here. How many centimeters in 7.8 meters? And we have a conversion here. It's just a single conversion. Now, this is our first problem with metric. And it's just one conversion. We've seen this before in the video. 100 centimeters equals 1 meter. So what you're looking for, how many centimeters, you put that over on the right. That's what you want to end up with. I'll just lightly write a question mark, some number of centimeters. That's what you want to end up with. You start off with 7.8 meters. That's over here. And meters to centimeters is a single conversion. We have it right there. So all you have to do, just draw one box. Okay, so again, we have two possible ratios. So you have these two to choose from. You want meters to cancel out and centimeters to appear on the top for the final answer. So the one that does that is this one. So 100 centimeters over 1 meter. Meters cancels with meters, and the last man standing is centimeters right there. That becomes the unit for your final answer. And so 7.8 times 100 is 780. And that's your answer for that. Okay, letter E. How many micrometers, and that's with that funny little mu letter there, are in 2.2 meters. So that what we're trying to find is micrometers. Even though it comes first in the sentence, and this comes second in the sentence, this is going to go at the end of the equation, and this is going to go at the beginning, because this is what we know, and this is what we don't know. So over here, I'm going to write the following. We're looking for micrometers. So here's what we have to do for that. We're trying to find micrometers. Okay, this one's got a little bit of a trick to it, so watch this. We're starting with 2.2 meters. Well, it really doesn't have a big trick to it, the way I've written the problem, okay? So we're starting with meters, we want to end with micrometers. And I give you a conversion, and again, you can write that. Commas are optional. I I should write micrometers, or the other way around, 1 meter over 1 million micrometers. So there's 1 million micrometers for every 1 meter, or there's 1 meter for every million micrometers. So which one of these two, you think about this, is going to make meters cancel out and micrometers appear at the end? It's a single conversion. And which one do you say? It's the one that has micrometers on the top, because that's what you want here in your final answer. And meters here cancels out with meters here, meters on top, meters on bottom. And there you got the last man standing as micrometers. And so your answer is, I didn't leave myself enough space here because it's a long answer. And it's not in scientific notation. This is normally a problem you would do in scientific notation because a million is a big number. So 2.2 times a million is going to be 2.2 million. So 2 million, I can put commas in if I want, 200,000. And that's your final answer. Okay, I'm going to leave F for you to do. Number 5, we're going to convert following decimal numbers to scientific notation. Okay, so we have 23,400. So you have a decimal right there. I'll leave this problem for you to do, but you already see where your decimal is there. This one sometimes tricks students a little bit, but where's the decimal? It's at the end of the problem. I think most students know that, but no. This one you already see where it is. This one you're going to do. So this is a U problem. Okay, I'll put U up. Okay, so here we go. So now we got to take this, and I always advise in any kind of math problem or science, don't write on the original equation. Just copy it down a second time. So there's my decimal. I need to create a number between 1 and 9.999. It can't be quite 10. It's got to be 9.999. Okay, so what's a number that I could create by moving the decimal? And the answer is I can move it over 1, 2, 3, 4. So if it's in between the 2 and 3, it becomes 2.34. 2.34 is a number between 1 and 9.99. So I'm going to write that up here. And then it's always going to be times 10. And you moved it over 1, 2, 3, 4 places, 4. And the only last question you have to ask is it a plus or a minus there? The answer is the original number is greater than 1, so it's a positive 4. This is a number less than 1, so whatever you get for that, I'm going to leave that to you, is going to be a negative exponent. Doesn't make it a negative number, makes it a positive number between 0 and 1. Okay? So there's the answer for this one. All right, you go ahead and do that. This one, we're going to go in the other direction. So what you do first is you write the coefficient down. And you look at the exponent. It's a positive number. If I'm going to move this decimal and I want it to be, it's a positive number, which means it's going to be a number greater than 1. Let's be clear what that means. Positive exponent means a number greater than 1. If I'm going to make this number greater than 1, the only way I can do it is to move the decimal to the right. If I move the decimal to the left, it's going to be a number less than 1. So I'm going to move it 3 positions to the right. 1, 2, 3. It goes right there. And so you got your egg carton here, so you put the eggs in like that. And so don't leave your answer like this. Go ahead and just write it cleanly. It's 4,200. If you want to put a comma in, you do not have to, but you would put it right there. Okay, you always, the way you do commas, you start from the decimal point and you go back every 3 positions is another comma. All right, so that's the answer to this one. Okay, you do that one. All right, now we're going to multiply. And 5.2 times 2.8. So remember what you do is you multiply these, the coefficients, and you add the exponents. Okay. So we got 5.2 times 2.8 equals 14.65, 56 rather. And 5 plus negative 3, that's the same as 5 minus 3, is going to be 10 to the second. Okay, so that's how you do that. Now we have to adjust the decimal. This should end up being a number between 1 and 9.99. So in order to get it there, I'm going to move the decimal over to here. So it makes 1.456. So I'll write that over here. And the simple reasoning you use is you just made this number smaller. From going from 14.56 to 1.456. That means you have to compensate by making the exponent bigger by 1. So that's going to be times 10 to the third power. So these two numbers, before I did that arrow, 14.56 times 10 squared and 1.456 times 10 to the third, are the same. They're the same number, same value. It happens to be 1,456. But both of those are 1,456. So there's your final answer. Okay? All right. Add parenthesis there, and you go ahead and do this one. You are going to have to do a decimal adjustment on that. All right? Okay, for division, I'll do two of these with you here. So what you're going to do here is divide. So I'll make a little divided sign there with the line and two dots. You divide those two, the top divided by the bottom, and you subtract the exponents. Okay? So 8.4 divided by 2.7 is going to give you 3.1. And then 5 minus 2 is 3, so 10 to the third. Okay, and that's your final answer. Since this is a number between 1 and 10 already, you don't need to adjust the decimal at all. All right, so there's your final answer. Let's do this one, okay? So this is 3.2 divided by 6.4. So again, this is going to be a division. And this is going to be a subtraction. So 3.2 divided by 6.4 is exactly 0.5. Times 10 to the... Now be careful. If you're not really good, even if you are really good with negative signs, I would write this down. Because watch, this is tricky, and I have students stumble over this all the time. I would almost say most of the time, but a lot. So it's -2 minus -7. -2 minus what's on the bottom, and what's on the bottom is -7. So the negative turns into a plus, so it's -2 plus 7. And some people, when they see that, would like to just flip it around and say 7 minus 2. That's fair to do. As long as you keep the sign with the 7 and the sign with the 2, you did. 7 minus 2, that equals 5. Okay, be very, very careful on those. All right, so this is going to be times 10 to the 5th. All right, all good. Now, again, we don't have a number between 1 and 9.99. So we're going to have to change this. So what we're going to have to do is move the decimal. This time we're going to go in the other direction from what you've seen so far. We're going to go over here, put it right there, and make that number 5. Instead of 0.5, it's going to become 5. So I'm going to come over here and write 5 times 10. Now think of what you just did. You made this number bigger. It went from 0.5 to 5, so you have to make this number smaller. And so 5 is going to go down to 4. Okay? And that's how you would do that, okay? All right, so go ahead and do this one over here. And this is a U problem right there, all right? Okay, now we're going to practice with some prefixes and units of measure, and you're going to convert these into scientific notation, all right? And again, the prefix, in this case, the M. Lower the camera down here. In this case, the C, the P, the capital M, the small n, the small p, the small mu for micro. Those are going to tell you what the power is, what the 10 base 10 to the exponent is in scientific notation. And the second letter, the grams, the meters, the hertz, you don't even have to know what that is to do this. The meters you'll learn. And farads, you don't have to know what that is. Just go at the end of the number. So let's just do a couple of examples, and then I'll leave a couple for you to do. So 320 milligrams. So we come up here, and milli is 10 to the minus 3. So that's going to be 320 times 10 to the minus 3. That the milli is that part, okay? And then it's grams. You just put the grams again. Now, we got to adjust the decimal. The decimal's right there. Whenever you don't see one, it's just at the end of the integer number. So you move it over 2 spots. Okay, so you become 3.2, and we'll go ahead and call it 3.20 times 10. Okay, so we made 320 smaller. And we made it smaller this time not by 1 position, but by 2 positions. We went over 1, 2. So we divided it basically by 100. 320 divided by 100 is 3.2. But the point is, you made this number smaller by 2 positions, so you have to make this number bigger by 2 positions. Now be careful. Which way is bigger? Is it -5 or is it -1? Both of those are 2 positions away from -3, but which one is bigger? Because that's what we need. The answer is bigger is going in the positive direction. That means to -1. -3 to -1 is going in the positive direction, so the -1 is bigger than -3. So that's going to be to the -1. And again, you just put grams at the end, whatever that unit of measure is, okay? All right, let's do another. 52 centimeters. So it's going to be 52 times 10 to the what? Here's centi. It's 10 to the minus 2. So it's to the minus 2. And then it's meters. It's that many meters. That's what centi means, is this part. So once you put this, you drop the C. You don't put the C in anymore. It's just meters now. All right, again, to adjust the decimal, so I'm going to move it over to here from 52 to 5.2 times 10. I made this number smaller by 1, so I have to make this number bigger by 1. Again, bigger is in the positive direction, so again, it's going to be from -2 to -1, so it's going to go to -1, and that's meters. So that was your final answer there. That's your final answer there. Okay? All right. 720 picometers. That's really small. We're talking subatomic right now, smaller than an atom. Okay, so 720 times 10. Pico is right there. 10 to the minus 12. Okay, and that's meters. Now this is one of those situations where you might leave it as 720. Here's the reason why you might not convert to a number between 1 and 9.9. Is that sometimes they want to standardize the exponent. They want everything, in other words, to be in picometers, no matter how big or small the number is. So they'd say just leave that as 10 to the minus 12. We're not going to do that here. Definitely when we get down to nanometers, we'll talk about that here. Okay, so I am going to make the conversion. So here's the decimal. I move it over 2 places. It becomes 7.2 times 10. So I made 720. I made it smaller by 2 positions. So I have to make this bigger by 2 positions. That means I'm moving in the positive direction. So think about it before I write it down. Which way is that? That's going to be to the -10. And that's in meters also. So there's your answer there. Okay, megahertz. That's what radio stations, 101.5 in San Diego is KGB. And they broadcast at 101.5 megahertz. All right, so we have 101.5 times 10. And mega is up here. It's 10 to the 6th power. So 10 to the 6th hertz. That's a unit of frequency that you may have used should have learned in physics actually. And it's just how fast the wave oscillates up and down as it travels through space. Okay, there it is. Now again, you may say you want to keep this in megahertz form, 10 to the 6. You may not want to change that, but just for practice, let's do it. So this is going to move over 2 spots right there to become 1.015. So we'll come over here. Times 10 to the. So we made this number smaller by 2 positions. It went 1, 2, smaller So this has to become 2 bigger. So that would be 10 to the 8th power. We're dealing with a positive number now, so it's getting bigger. All right, and again, that's hertz. All right, so I'm going to leave that. You have 3 more to do on your own. This is a U problem. So these are the ones I'm really going to look at when I look over your homework, is the U problems. Okay, I'll check to see that you did everything, but I'll really check a couple of them closely to see that you did them right. Okay. Finally, on this assignment, the last thing is, again, a U problem totally. That's to watch the video. It's the one if you got the assignment online, if you're looking at it on your computer screen, you can click right on that link, or it's in the Canvas. It's in the Canvas site, okay? So you can go ahead and do it there as well. But I just want you to write about 5 sentences to watch the video and describe the process and challenges faced by the researchers. Just summarize them. You don't have to give opinions or anything clever. Just kind of summarize what they say what they're trying to accomplish, what their challenges are in doing that. Okay, and that will be the last question. All right. All right, I'll give you a little time to share out in class tomorrow on this assignment if you're in period 1. And sorry I got this up so late, but you have time to do this. You can see it didn't take that long. It took about 30 minutes, and I was talking all the way through it. So go ahead and do these, and we'll present these in class tomorrow. Okay, that's it. So have a good day, and I'll see period 1 in class on Wednesday.